and then 10 means the most intense.
Sure.
Does that make sense?
Yeah, that's good.
Great. So then actually what we'll do is we'll just go like that.
Largest amount of pain I've ever been is when I had my appendectomy when I was 14. That was quite painful, but I've never actually had a capsaicin on me before, so I'm not quite sure what to expect. I was told it's sort of the active ingredient in chili pepper, so it's supposed to make you feel quite a burning, prickling type of pain, but yeah, we'll see how it goes really. We don't really know what is exactly going on inside the patient, what is the mechanism of action behind how the pain is generated. So if we look at their brain and see how their brain is processing their pain, the painful information, I think it's certainly going to be very useful in figuring out how different individuals feel pain differently and how we can manage that.
Okay, so you're going to go the rest of the way in, same as usual.
All the neurons that are in that part of the brain are firing away. They need energy to keep firing away as you remain in pain. And that necessitates a delivery of fresh blood, fresh oxygen to that part of the brain. And it's that feature that the brain imaging that we are able to localize our images onto. That metabolic signal itself is what we derive these images from. We'll just carry it on for a couple of minutes. So the blob here is really reflecting an area of the brain in which the metabolic activation of these neurons is very high. So everywhere on the screen that you don't see that red, you can say that actually the brain activation isn't necessarily any higher than what you would normally have. So it's just in these key regions here that the neurons are really firing away. The dorsal posterior insula, this region that I've circled here in the subject, is actually responsible for tracking intensity changes over time. So that's how we knew today to zone in here to show you, just in an individual subject that's suffering a very strong amount of pain, how active is this region. Cancer, diabetes, migraine, the list goes on. All of these conditions, they have an aspect of the pathology invokes pain, and that pain makes the pathology difficult to treat. And many would argue that pain itself is a related pathology in its own right. Minho, we're going to pull you out now, okay?
Yeah.
So, how you doing? I'm going to get you, what I'll do, you want to get up? Yeah. I find that to be really difficult to look at, but we can get you some images of that as well. But it's in chronic pain pathologies that we really enter into a new problem. And the problem is that those drugs don't work. So you give someone ibuprofen, it might treat it a little bit, but probably not. Give someone morphine, it might really work initially, but quality of life dramatically depreciates. And also things like morphine, opiates, they're addictive.
It has to do with fatty tissue, it has to do with, there are a lot of factors that go into why you get reddening of the skin. Now, mostly...
So it's like if you touch a hot stove, it kind of feels like that, but constantly.
Can we zoom in to this area here?
Now, these types of brain imaging techniques allow us to begin to ask these questions again with a much more meticulous and rigorous approach to zone in to the regions of interest that really we should be monitoring while we study new drugs, for example, new therapies.
Yeah, so that the reddening of the skin, the erythema, is actually a very interesting related